Here we have an example of solving a very simple kinematic problem in 2 dimensions. So keeping in mind that our general strategy is to separate out the x components and then do just a normal kinematic equation for the x components, then do a normal kinematic equation for the y components. Keeping in mind that that's our strategy, I want you to press pause, try to work through this on your own, and then press play when you're ready to go through it. Okay, so the first thing I'm going to do is write out my vectors, like for example my initial velocity vector is 2 meters per second and the direction is south. My final velocity vector is 15 meters per second at the direction 60 degrees southwest. And I'm asked, let's do the first part about the acceleration. So let's just remember what I'm going to be doing is solving for this x component first, and then solving for the y component of this. Let's look at solving for the x component. So I want to take this vector and figure out what is the x component of this vector. And then I want to look at this vector and say, what is the x component of this vector? Well, the x component of this vector is 0 because the vector is completely south. The x component of this vector is going to be negative because of the west. And I'm going to do 15 times cosine of 60. And I get negative 7.5 meters per second. So now I know v initial and I know v final for the x direction. I also know delta t is 10 seconds. And I'm trying to solve for my acceleration. You see how I kind of identified 4 kinematic variables, just like I did in all those previous kinematic problems. I know v initial, I know v final, I know delta t, and I want a. The only difference is I'm making sure I'm just looking at the x components of my velocities and my acceleration. So now I can choose the kinematic equation that involves these 4 variables. That's v final equals v initial plus a delta t. Here I've plugged in the values, and here I've solved for a. Let's do the same thing now for the y direction. So I'm going to get my y component of v initial and my y component of v final. So I have my v initial, I have v final, I also know delta t, and I want to solve for a. So those are the 4 kinematic variables that I want in my equation. So I pick my equation, it's the first one, and I plug in the values that I have, and I solve for my acceleration, my y component. Now I have an x component and a y component, and I can put them together to figure out the magnitude of my total acceleration. And I can solve for my direction of my total acceleration. I use the absolute values so that I get a number that's between 0 and 90. And then if I look at my x component is negative, that means west. My y component is negative, that means south. So here is my acceleration written in terms of the magnitude and the direction. Let's look at the second part of the question. Where is the object located? So that's going to be having to do with delta x and delta y. Okay. Let's just consider just the x direction at once. So I want to know delta x because that's going to tell me my final position. I know v initial x. I know my x acceleration. I just found that. And I know delta t. So I can choose an equation that involves these 4 variables. I'll choose that second equation. I plug in the values that I know. And I find that delta x is equal to negative 37.5 meters. That was my displacement. That's how my position changed. I want to know where's my actual final position, so I need to know where's my initial position. Well, I'm starting at the origin, so this displacement is also the same as my final position. Let's look at what's happening in the y direction. In the y direction, I want to know delta y. I know v initial y, I know my acceleration in the y direction, and I know delta t. That's enough to choose this equation. Here I've plugged in the values and I've solved for delta y. And again, because y initial is 0, this delta y is also y final. So that's my x position, that's my y position. Let's put those together to figure out, my distance from the origin. There's my distance, it's the magnitude of this vector. And I can take inverse tangent to figure out the direction of my vector. Both my x and y components are negative, so we get southwest for my direction.